Hello everyone, welcome to the channel. Today I was able to find an integral with a really nice trick to it for us to tackle. So let's just get straight into it. Cool, so here's the integral, and I actually found this integral on a free online booklet called the TBO Problem Solving Booklet. So I definitely recommend if you're looking for similar problems to get into. And yeah, let's dive straight into it. So I actually prepared a hint to try and find this sneaky trick. So I'm just going to pause now for a moment for anyone who wants to try the integral without a hint before I show the hint. Cool. So the hint I prepared is to try and divide the denominator and numerator by a common variable. So I'm just going to wait a moment again, just in case you want to try it with the hint. Cool. So let's get straight into it. So the first thing I notice is that, I think it's quite important to notice, is that this is a very awkward fraction, especially since n could have any value, and it could be a very large value, for example, and it's very awkward to integrate when you have 1 over a large polynomial. So there's this really nice trick to spot, which is if you divide both the denominator and numerator by x to the power of n, and when you simplify it, you produce this integral, which I'm actually just going to write like this. And all I've done is I've just swapped the +1 and minus n around. And this form is a lot easier to work with because it follows this equation, which is where if you have a function on the denominator and its derivative on the numerator, the integral of that can be multiplied by some kind of constant to produce the natural log of that function. So we know that the function we're working with is our denominator here, so we can work backwards. So if we try and differentiate the natural log of 1 plus x to the minus n plus 1, and we can do so by setting y to our function. And then we need to use a technique called chain rule, which is where we add an extra variable u in the middle between y and x to try and make our lives a bit easier. That's quite important, so we can put a box around it. And then we can just write y is equal to ln u. And I've just subbed this expression out for u. And then it's very easy to find dy du. It's just 1 over u. And that's also quite important, so we can chuck a box around that. And then we can do the same thing with u, differentiate u. So I just wrote it like this just to quickly show using this formula you can differentiate the polynomials nice and quick, and you get du dx is this expression here, which is also very important, so we'll chuck a box around that. Cool. So this is the important bits of information, and we can simply just multiply dy du by du dx. And this will mean that the du's will cancel out and you'll just be left with dy over dx. Just like that, and then I can write like this. And all I've done is I've just subbed out u for our for what it means in terms of x. So 1 plus x to the minus n plus 1. Cool. And I can write it like this, and this to clearly show that this chunk, which is actually was what we're trying to integrate, does come up, but we can clearly see that there's this minus n plus 1. There is some kind of constant there. So if we just refer back to the equation we're working with, we can clearly see that k is minus n plus 1. Because if we have a k here, this would integrate straight to ln of 1 plus x to the minus n plus 1. Perfect. We'll chuck a box around that because it's really handy. And now just working with final bit is we just need to sub in all the information we have. So we know our fx is 1 plus x to the minus n plus 1, just like that. And all I've done with this 1 over k is I've just taken the k here, divided both sides by k, and so you just produce 1 over k. And so that means now we're working with the integral we want. And we can sub k in, which we know is minus n plus 1. And then the most important thing is to make sure we don't forget our plus c, because we're writing a general solution. And that is our final answer, so we can chuck a box around that. And there you go, that's the answer. I really do hope you enjoyed the video, and I look forward to seeing you guys next time.